Hello everyone, welcome back to Algebra 2 lessons. Today we are going to continue our conversation from yesterday, which is find zeros of polynomials algebraically. As we mentioned yesterday, we actually use a factor to find out zeros. Today we are going to move on, not really moving on, but actually using similar way, but we are going to introduce a new type of way to factor. And before the lesson there, let's have a quick warm-up to review the practice we did yesterday. So as we mentioned yesterday, we do not have the graph of polynomial anymore in this case, so we are going to use factor to solve the answer, to find zeros of the polynomial. So the way we do that, always check, is there anything we can do to find the greatest common factor? So you can simplify this. Let's quickly check. So the number part, there's the invisible 1, there's 9, nothing we can do. But for the variable, they both have x. So I'm going to take this x out of this. Then it's going to be, this rest part is x squared, this is 9. And then this is equal to 0 because we're looking for zeros of polynomial. So the next part, you can simplify to just continue to solve it because each part is going to be 0. So two ways to do that. I'm going to use a different color. So to write one way, I can simplify, solve this as x might equal to 0, x squared minus 9 equal to 0. And then I plus 9 plus 9. And x squared equal to 9, then x, possible two values here. Do not forget it's going to be plus minus, so it's positive 3, negative 3. So now I have 0, 3, negative 3. Another way to solve it, I use green here. Another way, very similar, no big difference. So I'm going to continue factor because when I look at x squared minus 9, I'll notice, oh, this is actually difference of perfect square. So minus 3 plus 3. And then this are the three factors here. One of them might be 0 because according to zero product property, that's how you get them to get to 0. And this equal to 0 or x plus 3 equal to 0. Now I have 0, 3, negative 3. So same as this one, I have 3 solutions. And I also have 3 zeros. So it really doesn't matter which way you use, you will get the same answer. But this is one is just a factor. Let's see. So this is just the factor completely. Because in this way, we actually factor to the level, there's no more space for you to factor. But for the other one, you just, more focus on just find the zeros instead of, like factor to more steps. So as I mentioned yesterday, when we find zeros of polynomial, the good guiding question can like this. Can we use GCF like what we did just now? If we have two terms, please pay attention if there is any way we can use difference of perfect square. And three terms like we did yesterday after taking now GCF. Is there any way you can try the AM method? So today we are dealing with, instead of three terms, we are dealing with four terms. And we are going to try the one method called grouping. Some of you actually probably saw this before to create a chances to factor by grouping, and today we are going to look at this kind of example. So let's check the first one. The first one, as you can see, we have four terms here. So sometimes, and there's nothing we can combine like terms. So this is something we are going to try the grouping. What does that mean? The grouping is like very straightforward. It's like a group. So I'm going to write down this one. Factor by grouping meaning we are going to set up the groups. So the way we do that, look at the common thing. The two terms, you might have greatest common factor. So let's check the first part. X to the third, 3x squared. These are the two I can figure out, x squared. And then this one. So I'm going to deal with two separate parts. So what I'm going to do is, for each part, I'm going to use GCF. So I'm going to, for this one, I'm going to use, they both have x squared, then x minus 3. And for the second part, between they have plus, and then 2 minus x3. So if you pay special attention here, you would notice both of terms have x minus 3. So that's something I'm going to take it out. Take common part out. So this one is more like greatest common factor. So I'm going to, let's use a totally different color. So I'm going to take x minus 3 out of this. This is like the other way you think about it is as a distributive property. So the way we are going to do it is I'm taking the x minus 3 out. Remember, this is something you take out. So what's left? The left part, the first one is x squared. Remember, before you have x squared times x minus 3, you take that out. And then the left part for the second one is plus 2, because 2 times x minus 3. So now I have two parts. That's going to be equal to 0. And the way we solve it, as we mentioned yesterday, I'm going to deal with each part. This one is straightforward, x equals 3, because 3 minus 3 is 0. For this one, after we minus 2, you will notice, we are dealing with square root of negative 2 again. So the easy way to do this is going to be, by the way, do not forget plus or minus, because whenever you find square root, there's two possible solutions, and then we are going to deal with as this. So the answer is plus or minus square root I. You can put I in the front, you can put I in the back, same thing, but do not put I inside of the square root. So the three solution we have here, x is square root 2i, negative square root 2i, and 3. This is our 3 zeros here, but this is the way we called grouping. Okay, so some of you might find it's a little bit confusing to work on this process. So let's work on one more example. I think you definitely will have better idea. Okay, so let's check this one. So first, I'm going to group by two groups here. And then each one I'm going to use distributive property, take out the, not distributive property, sorry, to take out the greatest common factor. For the first two is m squared plus 9. Makes sense? Because that's they both have m squared. For this one, remember this is negative, so I'm going to take negative 2 out of this. So it's m squared plus 9. This is originally negative. After I take negative 2, it's going to be, oh, I think I made a mistake here. Let's rewrite this part. Sorry. So it's negative 2, but they both have m, is negative 2m, m squared plus 9. So if you don't say something in common, that's one thing you can also check. Did you take out the sign here? And then do not forget they both have m squared plus 9. That's something I'm going to take out of this picture. And then the rest part is, the first part is m squared, and then minus 2m. So at this time, you can definitely stop here, or you can continue to factor, like factor completely. So the first two parts, since they both have m, I'm taking m out of this. So this is what I get from here. And then I copy down the rest part. Okay, so that's called factor completely. I'm going to stop here. And then 1, 2, 3, let's solve them. M equal to 0, or m minus 2 equal to 0, or m squared plus 9 equal to 0. This is going to be final solution 0, and this is give us equal to 2. And this one, let's minus 9. Like we did yesterday, very similar, right? So plus minus. So m will be plus or minus. This one, I'm going to change it to this. And is that very similar? So it's 3i. So 1, 2, 3, 4. So it's 0, 2, 3i, negative 3i. Okay, so solving part is not different from yesterday. The only difference, as you can see, we have 4 terms here. We need to separate them by 2 groups, and we are going to take out the common term here. That's a little bit different from we take out 1 term, but we actually dealing with 2 terms. So you can definitely practice this kind of one, and this is called by grouping, and we are dealing with a little bit more terms here, but the idea is actually the same. Okay, thank you guys so much for watching this video and study this topic with me. See you soon, everyone. Take care.